Hey everyone, welcome to my course, Game Dev Bootcamp. This is week 5, lesson 10, and today we're going to be talking about state trees. Now, if this is the first of my videos that you're coming across in this series, this is a full series, and this is one of the lessons that we didn't get to in the last live stream. So I want to make a special video today just so we can make sure we cover this topic. And if you have been following the series, I have made a few changes to the project since we left off. These are mostly things that we've done before, but I just wanted to go through them really quickly because when I start this lesson, your project may not look exactly the same as mine, so we'll just review these really quickly. The first thing is I added some assets. In the last stream, I made like a pretty basic sword and I wasn't happy with it, so I actually swapped it out with one that was a little bit better. It's still not super fancy, but it's a little bit better than the one we made during the live stream. I also migrated the assets from the new Unreal Engine motion matching project. And if you're not familiar with this, when you go to the Epic launcher and you go to the news section, it says there's this animation sample project released. And when you click on that, it's going to open up this web page and you can make a project from this. It has a bunch of animations in it that we can use for our character. And specifically, I wanted the walk animations so that when our character is walking around, we get to have that 8-directional movement of their feet so that their feet are matching the direction they're walking. Now, we did this in the previous project, but just to review again, we needed to set up a blend space for our combat walk, and that's here. And in this blend space, we just have the idle, and then as the player changes direction, the feet are going to match the direction that they're moving. And we can see that here when I switch to my combat mode. Now we can see that my player character's feet are matching the direction that the character is moving, and this just looks a lot better. And then when I transition back, I can go back to the running and I can have this more free look around and then transition to combat, and the motion just looks a little bit cleaner. So that is a majority of what we did. So I added the assets. I migrated those animations from that other project. If you don't remember, you can just right click on the file and select migrate and then choose the project that you want to migrate them to. And then you'll have all the assets in your other project. And then we set up those animations in our animation blueprint. And I also set up the montage blending. And we also did this in a previous lesson, but it looks like this. So in this one, it's a little bit different. We have this main states that we're going to cache as the upper pose. And then we take our upper and we add in the default slot that gives us access to those animation montages. And then I'm going to cache that as full body pose. And then we're just going to blend by bone between upper and full. And in here, this is blending on spine _01. There, we can see it there. And all the rest is stuff that was already there. So when you set it up like this, you'll get this montage where when I switch to my weapon, everything looks good. The feet are still moving. I can swing my sword and everything looks a lot better than it did before. So that's pretty much all I've done to change this project. If you go back and watch the previous lessons to remember how that's done, then you should be right along with me right now. So in this lesson, I'm going to describe the state tree system. I'm going to create an enemy AI controller class, and then I'm going to create an enemy AI state tree class, and then we'll wrap it all together and implement a basic enemy AI using the state trees. So the first thing that I want to note is that the state tree plugin is still technically in experimental mode. That means there's some bugs. There's still a lot to learn. There's a lot of work that Epic has been doing to improve it. But if you are going to use it with your game, just know that you may get some buggy behaviors. Things aren't working perfectly, but I do think it's a really good system. And I think as Epic continues to develop it, it's just going to keep getting better. And I think it's going to be a good tool to have in your tool belt for building AIs. And actually, you could build a lot of things with the state tree system. It's not just for AI, although that's what we're going to be using it for. You could use this system to build some pretty complex game logic or a variety of things as well. So it's not just for AI. And at the fundamental level, state trees are comprised of two basic things. They're comprised of tasks, which are what the character in our case is going to be doing, and then transitions, which is how to handle moving between different states within the state tree. So when we talk about tasks, each state can have multiple tasks, so you're not just restricted to one task. And also, a state doesn't have to have a task. It can just be a state that handles some logic or something. And then one thing to know is that unless you set it up, all tasks within the tree are going to run concurrently as long as the state remains active. So it takes a little bit more work to control flowing from one to the next. You have to kind of think of it as everything's happening at the same time. They're all happening asynchronously, and you really need to control it if you want things to happen in a certain order. Now, transitions can point to any other state in the tree, and they have trigger conditions that need to be met. So we can have a trigger condition to enter a state and a trigger condition of when we exit a state, how do we flow into the next state? So let's go a little bit more into depth on both of these things. So like I said, state tree tasks are used to program the functionality of each state in your state tree. So basically, what happens during this state? What do I want to happen to the player or to the game, or just in general, what things should change or what actions should be taken? Now, there are 4 events that are built into a state tree task. There's interstate, so when you enter the state, you can have some functionality. There's exit state. When the state has been exited, you can have additional functionality. State completed, which has a pin for completion status. So you could have different things. For instance, if the task was successful or if the task failed, you can have a different branch based upon that enum. And then event tick, if you want a state to constantly be evaluated, then you can use the tick function on that state. Now, there's also a finish task, which is to be called when the task is finished. And then you can control whether you determine that the task has succeeded. So if you wanted to have like a branch with a Boolean, you could say, if the task is successful, then we want to mark this as finished task succeeded. Or if it wasn't successful, then we would mark it as not succeeded. And you could have each of those things handle some different functionality. State tree transitions control what happens after the state tree task has completed. And these are the key to controlling the flow in your state tree. And you'll see at the top, you'll get used to looking at these, but essentially what we're looking at here is we have a state called look for target. It has a task that is STT for state tree task, look for target. And then we can see that when the state completes, we want to move to the combat state next. And if the state fails, then we'll go down to the next task in the state tree. And we'll get to implementing all this when we build our AI, but this just gives you a little bit more detail about what we're going to be doing when we start setting this up. And I just wanted to provide kind of a high level view of how all these things are interconnected. So we have our state tree, which can be assigned to an actor in our game. And then each state tree has states. A state can have child states, and it could have any number of these. Each child state can be assigned to a task or to multiple tasks. And then you have state tree transitions, which control when a task is complete, what do we do next? How do we process through this state tree? And so how do we select new states? Well, we want to consider that we're going to start at the root of our state tree, and we're going to continue evaluating each state's interconditions. Now, if the interconditions do not pass, the selection moves to the next sibling state. If the conditions do pass, then the state is a child state, it is selected as the new state. If the state has child states, the same process continues onto the first child state until a child state is found. Once that state has been selected, the transitions dictate when and where the selection logic will be executed. So this is straight from the documentation. It might sound a little bit confusing, a lot of words in there about states and childs, but we're going to break this down and we're going to implement it into our game to make a basic enemy AI. So here I am back in my project. And the first thing I'm going to do is I want to create a new folder just to keep all these together. And I'm going to call it state tree. And let's go in here. And the state tree system is actually a plugin. So I need to go to edit, plugins, and then here I can type state and we'll get state tree. We want to put both of them on. So we'll select this gameplay state tree and state tree. And we'll get a notice that we need to restart. So we'll go ahead and restart. And once Unreal Engine restarts, if we right click and now go to artificial intelligence, we see that we have state tree is now an option. And here, this is important. We do just want to select state tree component schema. There's a state tree AI component schema, which if you are being intuitive, you may think that this is the right one that you want. But for this lesson, we're actually going to pick the state tree component. Just so you know, I did experiment with both, and I had some weird behaviors with this AI one that wasn't really what I was expecting. So I'm going to select this one, and then I'm just going to use st for the state tree prefix, and I'm going to call this enemy AI. And let's open this up and let's have a little look around to see what we're seeing. So we can see here in the middle, we have our root state. We can right click on this and add state and say add child state, add sibling state. Let's add a child state. And I'm going to call this one idle because I want to make some states under here that are for when the enemy is not in a combat state. And then I'll make another state, sibling state, and I'm going to call this one combat. And then we can add states under this to make states within those states. And if you're going to do this, one thing you want to do is with this parent state here selected, I do want to change the type. And if we look at the types of these, there's state, which is just going to contain task and child states. There's a group, and this is a state that just contains child states. There's linked, that is linked to another state in the tree. There's linked asset, which is linked to another state tree. So you can actually have a state tree that contains other smaller state trees and make it much more compartmentalized. We're not going to do that, but if you wanted to experiment, you could, where each of your states, idle, combat, so-and-so, link to another state tree, and then you can control the flow that way. So it's very modular, allows you to move things around as you need. And then subtree that can be linked to. So I'm just going to select group for this one and also for my combat. And then what is the first state that I want? I would actually like that the very first thing that my enemy is going to do is it's going to look around and see if it can find a player. So I'm going to call this first state look for target. And then the next thing that I want it to do is if it doesn't find a target, I want it to patrol around looking for an enemy, or I want it to patrol around looking for the player. So I'm going to create another state that's called find patrol point. And then I want to create another state that is move to patrol point. And this is going to be pretty much my idle state. So you can call this patrol if you want to instead, because this really is more of like a patrol. So this enemy is going to be looking around for a character. And then when they do find a character, I want them to move into this combat state. So in here, I can create some child states. The first one is going to be called enter combat state. And if you remember on our character, we have this input that can start or end combat when we press the tab key. And these are going to call start combat or end combat. So actually, because we set it up this way, we can actually just call this event on our enemy character through this, and that's what we're going to do. So the first thing we're going to do is enter combat state. We're going to call that enter combat state on our character. I'll add another state. And this one, I want it, once it enters that combat state, it's going to draw its sword. I want it to move to target. And I don't want that. I want that to be on the same level as this one. I'm going to add another sibling state, and this one is going to be attacking. So once we get within a range of the character, I want it to use an attack. And if you remember here, we did the same thing. We have this input that's calling an event called basic attack, which is this event. So we can actually call this event on our character, and it will perform the same attack motion that the player uses when they use the left mouse button. And then I'm just going to put one more state to show some of the capabilities. So I'm going to add a sibling state, and I'm just going to call this one wait. And this one's just going to have a small delay before we go back through the state machine. So this is just showing how all these states are set up in our game, but now we actually need to start using them. So on our BP enemy, we can actually add a component and type state tree. And then now that that state tree is added to the enemy base, we can use the dropdown and call enemy AI. So now our enemy base has access to this state tree, and we can start cycling through all of these states. But the states themselves don't do anything at the moment. We actually need to set them up. So for this, we're going to need some state tree tasks. And if you remember, this is a separate asset, so I'm going to right click, and I'm going to go to Blueprint class. I'm going to type state tree, and we can see here that there is a state tree task blueprint base. I'm going to select this, and my very first one is going to be look for targets. Let's do STT, look for target. Now you could do this any way you want, but I like to keep things simple, so I like to call them the same name as the state that I want to use it on. And so here I can add a task. So on the right side, I'll click this plus sign and then find my look for target task. And now we can see that look for target state has a task of STT look for target. And what do I want this to do? So let's go back and open our task, and we can see it looks pretty much the same as other blueprints we've used. The only difference is when we go to our functions, it just has these 4 states that we talked about. So interstate is the first one. And in here, I just want to perform some basic functionality. And I'm going to keep it really basic. I just want to check if the player character is within a certain range of this character. So I'm going to create a branch here, and there's a node called get distance to. And this node will take in a target actor and then another actor. So for our target actor, we can actually just use a reference to ourselves, but I actually want to create a variable for this. And I like, just to make sure that things are very clear, I like to create a variable on every state tree task that's called owning actor. And I like to set this to the variable type of enemy base with a object reference. And there is actually some functionality built in using the category. We can call this context with an uppercase C. And this will actually send a flag to the state tree saying that this is the owning actor of the state tree. And then I can pass this into the target. And then the other actor is going to be the player. So I can actually just use get player character. And it's going to check the owner of this state tree task versus the player character. And we want to check if it's less than a number. And you can create a variable from this. We can call it detection range. And I'll just make this something like 500 for now, just to get it working. Now, with the way we set this up, if the owning actor is less than the detection range, then we can call finish task, and we can do succeeded. You could do it either way. In this case, I want this to tell me that the task did not succeed. So if the player is greater than that distance, then we're not going to succeed. So if the player is less than the detection range, Then I want to get this player character again, and I'm going to cast this to BP character, and then I want to set this as a variable on my enemy base. So I'm going to create a new variable on my enemy base called target actor, and it's going to be of type BP character. And then here I can get my owning actor and set target actor to this actor here. So if the owning actor is less than the detection range to the player character, then we'll call true on this branch. Then we're going to get player character, cast it to BP character, so we can set that as the target actor on our owning actor, which is the enemy again. And then the last thing we need to do, I'll just grab this and copy it, and this is going to be the succeeded pin. So now our first task is set up. What we want to do next is set up the conditions of how we're going to proceed from this point on. So if you remember, if it fails, so here we'll add a transition and we'll say on state failed, then we just want to go to the next state. So we can see now this X is pointing down. So if it fails, we're just going to go to find patrol point. If it doesn't fail, meaning it succeeded, so if on state completed, we want to transition to combat. So what this is saying is, if we find a target, let's go to combat. If we don't, we're just going to go to the next one, which is find patrol point. So let's set up our next state. So we'll go back here. We're going to create a new blueprint task. We're going to type state tree again and get a new task. Select, and I'm going to call this one find patrol point. And for this one, I actually just want to create a basic actor. So I'm just going to say actor BP patrol point, and I'm just going to drag a couple of these in, just make a few of them in my level, and I'll take my enemy, I'm just going to move it over here, and on patrol point, let's use the interstate. And all I'm going to do here is say get all actors of class, patrol point, random array item, and let's say get world location. On our enemy BP, we can create another variable called target move location. This can just be a vector, and let's get our owning actor and set move location, and we'll set that to this location. And then we can call finish task, succeeded. And then here we can add that task, find patrol point, on task completed. Let's go to the next state, which is going to be move to patrol point. So let's set up that task now. And this one's going to be pretty straightforward. We just want to use an AI move to. Now, you could argue that we don't really need this find patrol point, and you could just migrate that all into one task. You could do it however you want. I'm just trying to show a little bit more complexity so you can kind of see how these things work. And hopefully it gives you a better grasp of how to create your own state trees for your game. So let's promote this to a variable called owning actor. And we want this to have the category of context. And this should be enemy AI, enemy base. And on here, we want to get that target move location and use AI move to on that. And then this is pretty easy. We can call finish task if it succeeds or if it fails. And when it fails, we can say it did not succeed and then set those states accordingly. So let's add our task of move to patrol point, and on completed, we can go back to patrol. So it's going to loop back up to the top here. And I guess in that case, we don't really need these, but if you wanted to have some different functionality, if it failed, you could just add another transition, and on state failed, maybe you only want it to go back to the patrol point. Maybe if it makes it to the patrol point, you want it to wait a second or two there, look around or something, and then cycle back through it. So you could just kind of do it whatever way you want. So all of this looks set up now. The only thing we need to do is we've been setting on all of these states this owning actor, and it's in the context. One of the things we need to do is on our actual state tree, we want to set this context actor class to enemy base, and that will allow everything to be working. You can see here now in context, it says enemy base, and that should be working. All right, and there's one more setting we got to change on our enemy base. We do need to change this auto possess AI. It's under the pawn section and our class defaults. We need to change it to placed in world or spawned. And this will allow the AI to take control of the character when it is in the world. And now if we press play, we should see that our character is running around between all of those points and is just picking them randomly and cycling through them. But it's not interacting with the player yet because we haven't set up any of the combat behavior. So let's go ahead and do that next. So let's first set up this enter combat state. We need a new task for this. So let's again go through the motions of this state tree. And we want to set the enter state. And again, I want to create my owning actor. Remember to always set the category to context, and that way it'll just grab it in the state tree. It just knows what to do. So we'll get this, and then we can get the gameplay tags from this. And remember, we set up so that there is a combat state. So we can say has tag, find that combat state. And we can actually use this to enter or leave combat. Now for this, we're only going to be entering combat. Basically, once we see the character, we want to fight it until one of them dies. But if you wanted to set up something differently, where maybe there was a state where if you get far enough away, it'll reset, or if the enemy gets scared and runs away after a certain time, maybe it'll try to reset. So you could do a lot of that. And in that case, you wouldn't need two different states. You could just use set combat state to either enter or leave combat. And we can use this owning actor variable again to enter combat. I can't remember what it was called. Start combat. And then we just want to finish task. But again, if we wanted to set up some future functionality here, we could have this true pin go to end combat and then still want to finish this task. And now here, let's add that task here, set combat state. Now we want to do the next one, which is move to target. And for this one, it's going to be pretty simple. We will again create our owning actor. Let's get this. Let's get our target. Get target actor. And I just wanted to use a validated get for this just to make sure we actually do have a target. If we do, I'm going to call AI move to. And the pawn is going to be the owning actor, and the target actor is going to be the target actor. And I can also use this is not valid pin to tell me that this task has not succeeded. And then I will copy that twice. Once will go into fail, once will go into success, and the success one we want to mark as succeeded. And that's all that we need to do there. So let's set this one up, move to target. We want to have a task, move to target. The transitions, we want 2 of them. On state completed, let's go to the next state, which is going to be attack. And if the task has failed, then we want to reset back to the root and start over again. And the last one we need to do is this attack. So let's go through the motions one more time. We'll create a variable, owning actor. And for this one, we can just call basic attack and then finish task. Now back in our state tree, let's add that task. Set up our transitions. I want 2 of them. I want a failed one that goes back to the root, and I want a completed one that goes to the next state. And the last one is going to be a waiting state where we just want there to be a slight delay. Now the beauty of this is there's already a built-in one called delay task where we don't actually need to set up a task. We can just set a duration. So I'm going to set a duration of 1 second, and then we'll go back up to the root and reevaluate. I did forget to do one thing. This intercombat state, we forgot to set up our transitions. So let's go ahead and do that. On complete, let's go to next. On fail, let's go to root. And now we can see that the character is just going to try to come after the character and try to swing the sword at it. That is a little bit weird. So one of the things we can do is this wait task. When it completes, instead of going to parent, we can have it go back to move to target. So after it gets done waiting, it won't reset back to the root and start over every time. It's going to try to attack the player and then continually try to move after the player and attack it. So as we can see, we now have a basic AI system that's pretty functional. We can do a lot more work in it, but hopefully you have a better understanding of how the state tree system works now, and you can use this to build onto your project to set up any other state tree that you want. There's a lot more to it. We didn't even talk about state tree evaluators, which are what allows you to pass data in and out of your state tree. So you may have noticed that there's this parameters here. One thing to know about state trees is these parameters can be information that you could use in your state tree, but they are hard set. You can't ever change them. They're just static variables. So I haven't really found a use for these, but you can set up parameters, but just know that you can't actually change those once you have them set up. So we'll continue to build upon this through the rest of the course. So this really is just an introduction, get you learning about state trees, get you starting to think about it. But you can see here that we have a very dynamic system that took a little bit of setup, but now we've already got all these tasks set up, and you could set up different AIs for different characters very easily now that all these things are set up. So hopefully you learned a lot. And I'll see you in the next lesson, which is going to be the live stream for week 6. Thanks for watching.